Hello dear children, this is Preeti Chhabra and I welcome you all to Learning Never Stops. Today we are going to do the third and the last part of the lesson, study of gas laws. Okay, in the last video we had seen the Boyle's law, that is the relationship between the pressure and volume of a gas, correct? In this video we will be doing the relationship between temperature and volume of a given mass of gas, keeping the pressure constant. As in the last video also I told you in the last class that when we are doing the relationship between, studying the relationship between two variables, then the third has to be kept constant, and of course the mass of the gas has to be kept constant. Okay, when you celebrate your birthday, what do? You decorate your room with the balloons. लेकिन all of a sudden एक balloon burst हो गया, होता है ना ऐसा? तो what is the reason behind that? जब टेम्परेचर राइज होता है, या फिर आप एक इन्फ्लेटेड बलून लो, उसे ओपन सनलाइट में, ब्राइट सनलाइट में रख दो, व्हाट वुड हैपन? गर्मी की वजह से अंदर की गैस का टेम्परेचर, जो इन्फ्लेटेड बलून है, बलून के अंदर गैस का टेम्परेचर इंक्रीज़ होगा, है ना, काइनेटिक एनर्जी इंक्रीज़ होगी, तो टेम्परेचर जो राइज होगा तो काइनेटिक एनर्जी इंक्रीज़ होगी. दैट वुड लीड टू द एक्सपेंशन ऑफ द गैस एंड देन द बलून वुड बर्स्ट. फाइन. तो directly we can see that जैसे ही temperature increase हुआ, that led to an increase in the volume. So they are directly proportional. Okay. Now in 1787, a scientist named Jacques Charles studied the relationship between this temperature and volume, and he gave a law. What did the law say? According to the law, keeping the pressure constant, the volume of a given mass, this is also constant. So the volume of any given mass of a gas would increase or decrease. It would increase or decrease by 1/273 of its volume at 0 degree centigrade. At 0 degree centigrade, listen carefully, keeping the pressure constant, the volume of a given mass of gas would increase or decrease by 1/273 of its volume at 0 degree centigrade for every rise or fall, for every 1 degree rise or fall in temperature. Now let us see the mathematical expression of the law. Suppose V naught, let V naught be the volume at 0 degree centigrade. 0 degree centigrade पे suppose this is the volume, and let V be the volume at any temperature, say T degree centigrade. अभी हमने statement में क्या देखा? For every 1 degree rise or fall in temperature, there is going to be an increase or decrease respectively in the volume by what? By 1/273 of the volume at 0 degree centigrade. What is the volume at 0 degree centigrade? It's V naught. So for every 1 degree rise, it would be 1/273 of V naught. So for T degree rise, it would be 1/273 of V naught into T times. So V would be V naught जितना 0 डिग्री पे था, प्लस अब T टेम्परेचर पे जितना इंक्रीज या डिक्रीज होने वाला है अकॉर्डिंग टू द टेम्परेचर गिवन हियर. So it would be 1/273 of V naught T times, correct? So this is V is equal to V naught plus V naught by 273 into T. Okay. Now from here we can take V naught constant, common. So here we'll get 1 plus 1/273 into T. Clear? Now this is V, volume at the given temperature. Now after calculating this, we get V is equal to V naught. This would be, take the LCM, 273. So here we will get 273 plus T. Fine. Now What is 273 plus T? What is this T? This T is the temperature in degree centigrade. Now, if you add 273 to the temperature in degree centigrade, you will get the temperature in the Kelvin scale. We have done this in the last video. So, this would be equal to V naught. Now, let 273 plus T be capital T. This is the temperature in the Kelvin scale, okay, by 273. Clear? So, what is the volume of the given mass of a gas at T degree centigrade temperature? That is V is equal to V naught by 273 into T. And what is this T here? This is the temperature in the Kelvin scale. This is very important. This capital T is the temperature in the Kelvin scale. Okay. Now, this is constant temperature of a given mass of gas at 0 degree. That is by 273 is a constant term, is a constant value, sorry. This being constant, we can write this equation as, I'll write it here. From this equation, we can say that V is equal to, this is a constant value, K into capital T, and this is the temperature in the Kelvin scale. So, here, from here you can say that V is directly proportional to the temperature, and which temperature? The temperature in the Kelvin scale. Okay. So, the law, it can also be stated as the volume of a given mass of gas is directly proportional to the temperature in the Kelvin scale. This has to be mentioned. Keeping the pressure has to be kept constant. Okay, the pressure has to be kept constant is important to be mentioned, and the the temperature is in the Kelvin scale here, to which the volume of the given mass of gas is constant, has to be mentioned. Now, let us look at the equation of the law. For that, let us say, let V1 centimeter cube be the volume of a given mass of gas at the temperature T1. So, V1 is directly proportional to T1, and let the volume be V2 centimeter cube at temperature T2. So, V2 is directly proportional to T2. Okay. Now, V1, since it is directly proportional to T1, so we can write this is equal to, with a constant we can write it like this, and here V2 is equal to constant and the temperature T2. Okay. From this we can write V1 by T1 is equal to the constant K, and V2 by T2 is also equal to the constant K. So, from these two equations we can say that V1 by T1 is equal to V2 by T2, which is a constant. Okay. Now, let us see the graphical representation. This is the x-axis. Here we will take the temperature, and the y-axis will take the volume. Okay. Let's mark 0 degree centigrade here. Then suppose this is 100 degree, then 200 degree, then 300 degree, and here we would take 10 centimeter cube, then 20, 30, 40, 50. Now, we know that volume is directly proportional to temperature. So, we should get a straight line here, but can this be the origin point? Can this 0 degree, this O, be the starting point? No, because we know, just now we have seen that volume is directly proportional to the temperature at what scale? At which scale? At the Kelvin scale, okay, and not the temperature in the centigrade scale. So, we have to plot the graph with the temperature in the Kelvin scale, that is absolute 0. Now, what is the absolute 0? Minus 273 Kelvin. Okay. So, this is going to be the starting, the origin point, because this is the temperature, this is the absolute 0 in the Kelvin scale. So, you will get a graph like this, and then you will get a straight line. Okay. So the starting point has to be minus 273 as the volume is directly proportional to the temperature in the Kelvin scale and not this 0, because this is the temperature in the centigrade scale. So this is the graphical representation of the law. Now we have studied the relationship between pressure and volume keeping the temperature constant, and also the relationship between temperature and volume keeping the pressure constant. That is the Boyle's law and the Charles law. Now let us see into the gas equation, whereby we will be studying the relationship between all the three variables together in a single equation. Okay, pressure, volume and temperature. What would happen if both pressure and temperature are varied? Here only pressure was being varied, here only temperature was being varied. But what will happen if both pressure and temperature are varied? So according to this equation, what was the equation? V proportional 1 by P, and here according to this law, V was proportional to, or rather V is proportional to T. Combining these two equations, that is combining the Boyle's law and the Charles law, what we get? V to be proportional to T by P. Okay, so V is equal to a constant T by P. Okay, so PV by T is a constant. Clear? So this is the gas equation, whereby we can see the relationship between all the three variables. This is the gas equation. Gas equation. Clear? Now from this equation we can say that if the volume of a given mass of gas changes from V1 to V2, the pressure changes from P1 to P2 and the temperature changes from T1 to T2, then according to the equation, P1 V1 by T1 is always equal to P2 V2 by T2. This is the gas equation. Now अभी तक हमने जितनी भी स्टडी की, we found that प्रेशर में चेंज हो या टेम्परेचर में चेंज हो तो वॉल्यूम रिमार्केबली चेंजेस, है ना. प्रेशर में चेंज हो तो वॉल्यूम में चेंज, टेम्परेचर में चेंज हो तो भी वॉल्यूम में चेंज. टुगेदर ऑल्सो वी सॉ कि जब दोनों में चेंज हो तो भी वॉल्यूम में चेंज. दैट मीन्स देयर हैज़ टू बी सम स्टैंडर्ड वैल्यूज़ फॉर सम स्टैंडर्ड सेट वैल्यूज़ फॉर प्रेशर एंड टेम्परेचर. उन स्टैंडर्ड वैल्यूज़ से वी कैन कैलकुलेट कि टेम्परेचर में अगर ये स्टैंडर्ड टेम्परेचर वैल्यू है, देन उससे अगर चेंज होता है टेम्परेचर उस स्टैंडर्ड वैल्यू से अगर कम या ज़्यादा हो तो वॉल्यूम में क्या चेंज होगा, एंड स्टैंडर्ड टेम्परेचर पे या स्टैंडर्ड प्रेशर पे क्या वॉल्यूम होना चाहिए गैस का. तो टेम्परेचर, फॉर द टेम्परेचर द स्टैंडर्ड वैल्यूज़ आर 0 डिग्री सेंटीग्रेड और 273 Kelvin. Okay. For pressure, the standard values are 1 atmospheric pressure or 760 mm of Hg. Okay, these values are the standard set values. Temperature में इससे change above that और 0 डिग्री से कम अगर चेंज हुआ तो वॉल्यूम में क्या चेंज आएगा, दैट फॉर गिवन मास ऑफ गैस. और अगर प्रेशर, दिस इज द स्टैंडर्ड वैल्यू, अगर इस वैल्यू से प्रेशर कम हुआ या ज़्यादा हुआ फिर वॉल्यूम किस तरह से वैरी करेगा. नाउ थ्रू आउट द चैप्टर जितना भी हमने पढ़ा ये स्टडी ऑफ गैस लॉज, थ्रू आउट द चैप्टर वी हैव बीन सेइंग दैट fixed mass of a dry gas. Why a dry gas? Suppose hydrogen and nitrogen, these are the gases which can be collected over water. जब ये water के over collect होते हैं, they become moist because now when they are being collected over water, what do they contain with them? They are not more dry. They contain water vapor with them. Fine. तो अब वो जो moist gas pressure exert करने वाली है, that is not alone due to the gas. उसमें कौन सा pressure है? Gas plus the pressure due to water vapor. क्योंकि now it is a moist gas, right? Gas plus water vapor. But we are studying about the gas laws. We are studying about the pressure of the gas and not of the gas plus water vapor. So gas plus water vapor यानी moist gas का जो भी pressure होने वाला है उसमें से we have to deduct, we have to reduce the pressure of the water vapor to get the pressure exerted by the gas alone. That would be the pressure exerted by the dry gas. Okay. Now, if the pressure is being exerted by the moist gas, so what would be the total pressure? Total pressure would be the pressure which is being exerted by the gas, but the gas is not alone, plus the pressure which is being exerted by the water vapor. Since it is moist, it carries water vapor in it, right? So, this pressure which is exerted by water vapor, the partial pressure of gas plus the partial pressure of water vapor. So, the pressure which is due to the water vapor, it is also known as the aqueous tension. Aqueous tension, okay. Now, this is pressure because of gas plus pressure because of water vapor. So, what would be the pressure due to gas? It would be total pressure minus the pressure due to water vapor. So, if you deduct the aqueous tension out of it, out of the total pressure, you will get the pressure exerted by the gas alone. Now, this would be the dry gas, and we always study the laws with the constant mass of the dry gas, because what we are studying the gas laws. Okay. So, that's all for today. In the next video, I will be doing some numericals based on these laws. Okay. For that, you need to subscribe to the channel so that we can meet again. Till then, take care. Bye-bye. Thank you.